So we'll talk about data modeling in SAP HANA. Again, there's no prerequisite for this course, for this lecture. It's for business students, information system students, and also computer science students. So we'll get to know the data modeling process in SAP HANA, how to use and navigate, how to use in web IDE. As you know, that we are using Google Chrome, and then we are using web integrated development environment. Okay, so we'll see how we can use and navigate this web IDE. We'll talk about data types which SAP HANA supports. We'll try to see the overview. We'll try to know the join operation in calculation view. Remember, join is one of the most important things. All the time we are working on join. So this is very interesting topic. And we'll try to understand the basics of calculation view, how to create and about that. HANA data modeling overview. Any application you develop or any database activity you want to do, the first step is always requirement analysis. That you have to interview the people, you have to talk to the people, you have to see the documentation, and try to understand the requirement of the user, that what the user wants from these documents, what kind of report he's interested in. Then we'll look for what kind of conceptual model we can work with. We have like semantic data warehouse model, we have like multi-dimensional fact models and adopt models. I was just looking at some pictures of the some of these models, like for example, this is one of the model there. So in this type of model, we prepare for the then we do some observation we ask people and we discuss, and then we put the plan together. This is like a strategy that we are using for our in our conceptual modeling. Then we do the logical modeling. This logical modeling for your reporting analysis. Okay, so maybe in this conceptual modeling, we might be preparing the tables, getting to know the tables of our that we will be using in our report. But in logical modeling, in the logical modeling, we will be linking the tables and the fact tables and the dimension tables that can help us in preparing the reports. So this is another example of logical modeling. And once we are done with that logical modeling, then the physical modeling. Okay, then we will be creating the tables, and we will importing the data, and then do the processing. So this is the data modeling process in SAP HANA. We have seen this diagram before as well. We are getting data from different types of sources into HANA. Okay, and this is the through the data provisioning, going data into the tables, and with the help of view, we are bringing to the front end. Okay. And now if you see here, we are having SAP Lumira. Lumira is also a web-based software. Before it was a separate software, like an application, like we are having Word, Excel, PowerPoint. It was like a window-based software. But now they are moving everything to the web-based. So you can have access to the reports with the help of these tools or the front end from there. We have seen this diagram before. This is the HANA platform. All the data management is happening on the database level. Okay. Then we have application development. We have like um, processing, the analytical processing, spatial processing, the graph, the seas, and streaming analytics. Streaming analytics means we are getting the data from the sensors. Predictive modeling, what customer is going to buy in the next month or next. If any customer buy like milk, then what is the other thing that he can buy? So based on those analysis, they group the things together. So they found out the pattern. The customer who is buying milk is going to buy the yogurt as well. So you will see they always put these things together. So yeah. And then this is the data visualization, that you can get the data from other sources and have a look at the data. So this is the HANA platform that we'll be using for our analytics. We do have a HANA Studio. This is a software like that can, so it has like three different areas. One is for development, one is for modeling, and one is for administration. In the administration, if you remember, some of you guys, one of you has like lost the password, and she was not able to access the SAP HANA. These kind of activity we do on the administration perspective. Reset the password, lock the user, activate the user. And in the modeler, we have to do the data modeling, the dimensions and the fact tables. We have to create the attribute views and the calculation views in the modeling. The development is for application development, like a mobile application development you want to develop. And so we'll be doing in the development perspective. So we have three different areas in HANA Studio. That is what will be. So if you install this one, then you'll find all these three things. We do have like web ID. Now this is one thing. Either you use the HANA Studio, or you can go for web IDE, that is integrated development environment. So both have their benefits, and now if you see the okay, this is what I think we have seen already. We have seen this screen, because last time when we logged on to the system, we were on this page. So this is what they are trying to show us. This is a workspace. This is the database. These are the settings. And the workspace, we have like, we add the database. We have another database, you see. We have another database. Oh, mashallah. So 4 or 5 different databases, we linked into this workspace. We can develop our, programs, develop the models based on our data. So it allows multi-target application. You have like, many databases, as we have seen here. We have one database, data mining database, another database, another database. So these are like MTA, multi-target applications, and we are working on that. So this is again a close-up of the same page. This is the project, guys. In the workspace, we have a project. So the first is project. The next one is the database, that we are going to database module. These are the folders. SRC is a folder. So this is actually, these are all folders, but here in this part we will have database modules. And you will you'll see the. So this is our development tab. So we have like database explorer. When you open the database, you can when you write the SQL, you can debug the SQL, guys. SQL stands for sequential query language. And you want to extract information from the table, you need the SQL. We have an SQL console. again, you should be in the Database Explorer. So if you click on this button, this is the Database Explorer. If you click on that, then you will see the databases. Let me go back if I can find. Not here. So you will find databases, and you will find the console, SQL Analyzer, and all these will be available on the, if you see the button, can you see the button here? If I can increase the size of the button, you see here. This is the database button, Database Explorer. So if you click on that, you will see all these things available in that. So this will allow you, when you go to this one, it will allow you to view the database contents, and you can use the database content into the calculation view, or you can have the stored procedures, and So in Database Explorer, this is our HDI container database. So HDI container has all the, you see, objects. So one of the object is database, tables. Another one is triggers. Another one is view. So you can create different views, triggers, and tables, and so many views, so many objects are there. So the first line is your HDI container database. So first of all, again, same thing. We have to select the data. Okay, it could be a transaction data, it could be a master data. For example, customer is a master data. Okay, customer data is a master data. Product is a master data. Sales is transaction data. So we can select master data. We can select transaction data tables from any source like ERP, SCM, flat file, Access, Excel, So, and then we will create the physical table in HANA because we want the reporting. So we will get the data from outsource, from outside, through the data integration. We will move we will create the physical table in HANA, and we'll move the data into the HANA. And then we will create the calculation view. There are two types of views we can do. One is type dimension, and one is type cube. Cube is like, this analytical view. So the type is cube and dimension. Dimension means you cannot do any calculation on this type of view. Okay. So, I told you we have an attribute view, we have analytical view, we have calculation view. We were talking about 3 different views. Actually, there is only one. From this slide, we can see that there's only one view. What is that? Calculation view. This calculation view has 2 different types. One is dimension type, one is cube type. So the dimension type you cannot use for calculation, but you can use it for dimension of reporting, like cities-wise reports, country-wise report, product-wise report, customer-wise report, sales organization-wise report. And this cube means that we are going to have dimension and the fact table. And yeah, columns view are generated in the database. So from this view, you can see the data, or you can see the, charts, pie charts or line charts, or whatever the way you like. Okay, now if you see the data table, I think we already talked about that. This is the table name. This is the table name. Database schema, where the database table type. This is the column table type. I think this is the old slide. We have like new one. This is the field length. Data type is this one, decimal, and these are the fields of the tables. So when you open the table definition, you will see all these things. Now, let's have a look on the data types. We have the text. All the text are strings. Yani variable character, This is like ASCII format. American Standard Code for Information Interchange. This is the basic, the first one ever developed by any computer guys. This was the variable character or simple characters. Now we have nvarchar, nvarchar. This is variable character. This is the Unicode. So data is stored in Unicode. Here the data is stored in ASCII format. Here I think data is stored in byte. Here the data is stored in 2 bytes. In every character, for example, Tariq, T is stored in 2 bytes. A is stored in 2 bytes. So every letter will be stored in 2 bytes. But in this case, in variable character, T will be stored in 1 byte. A will be stored in 1 byte. So then we have like a large string and NCLOB, large object. Okay, so we do have a date and time type. We do have a floating like double, decimal, real. These are the numeric types: integer, big integer, small integer, tiny integer. These are the examples for the data types. And these are the types of data we can have in our HANA. We do have some others: array and Boolean and var binary and blob and large binary object. So these types of data, these are the types available for using in SAP HANA. Now we do have some special data types. These are the points. Special data types is used for for the locations from this city to another city, from this location to another location. So these are the. Then we have like large object. I think large object are like maximum value you can store is like 2 gigabyte. 2 gigabyte in one column. You can store this much long text. If you see the level of modeling in SAP HANA, we have like calculation view. So calculation view, okay, guys, please write in the chat. In the calculation view has 2 types. Can you please name those 2 types in the chat? Okay. That is one. Okay, I accept it. Calculation view has, calculation has, okay. Miss Hissa, your one answer is correct. One answer is, no. I mean, I said calculation view has 2 types. I've dimensions and the cube. Very nice. So if you see here, we have calculation type. It is mentioned on the screen is dimension. And we have a calculation view that has a cube. Okay. So in dimension, you see we are getting the master data. You see that? Master data. Master data for material, master data for products. Okay. And now in this plus, so this was the dimension, plus the fact data, that is the sales transactions, all the transaction. So these 2 becomes the calculation view and the type is cube. So we will create from this dimension plus this table, we'll create the calculation view of the type cube. And this will be like multi-dimensional information model. And in this creation of this cube, we will be using select statement. We will be using join. We will be using union. We may use projection, aggregation, or rank. We can use some of them. We can use all of them. These are the operations that we can do on the data, on the master data and the sales data, fact data. We can do all these things. As a result, what we will get? We'll get the calculation view. This is the level of modeling in SAP HANA. We start with creating a dimension. We will have a fact table. With these operations, we will be creating the calculation view. Any question, guys, here? Thank you, Sumaya. Now we go to the join operation. Guys, we have different types of joins, okay? Now, these are two tables, huh? ABC and CD. They are two different tables, guys. Now, these two tables, we can join these two tables. They are separate table, okay? They are separate table. ABC is one table, CD is another table. Now, I want to join them. Is there any common column between the two tables? Yes, the C column is the common between the. So I will be joining, I will be making an inner join on these two tables on these column. Then what will happen? I can join the result of the, so at the end of the day, I will get A, B, C, and D column. So it will become one table. When I will do the inner join on two tables, it will become one table, like that. So what it will do, it will exactly match. It will exactly match C1 to C1, C2 to C2. Oh, C2 is not available. So it will not display anything for C2. For C3 to C3, oh, there's nothing. So it will not display anything except C1. Only the matching one rows will be displayed. So you see that in these two tables, only one row is matching. So that is why we get, as a result, we get one row. Make sense? Inner join mean equal sign. Okay, now we have like full outer join. Oh, they directly come to the full outer join. Okay, yani in this kind of join, again, we will do the same thing. We will do the same thing. Yeah. So we will get the matching. You see, we will get the matching. That is the first thing that we got the matching. We got the matching, the first line. Then we will get everything from one table, whether it has a matching or not. And then we get the second table, everything from second table, whether they have a matching from the first table or not. So we will display like that. Okay, this is what we call full outer join. Remember, guys, we will be using lots of join in our case study. Oh, 3 joins, huh? 2 or 3 joins, inshallah. But we should know, and we will be using like inner join. Okay, we will not be using outer join or full outer join or something like that. Now we have a left outer join, guys. Left outer join means this is the left table. Okay, ABC is a left table. So we will get everything from ABC table and only the matching from the right table. This is what we call left outer join. Okay, so we got only the matching from the right both table, and which is not matching everything from the left table. Yeah, null value, these are the nothing, null value. So they will be appearing in the outer join. Yes. In this column, when we have no matching, it will come like that. So the left mean left table will get everything. Left table will display everything. And on the right table, only the matching one will be displayed. Bas. This is what we call left outer join. Similarly, the right outer join, we will get everything from the right table, only the matching one from the left table. Guys, is that clear? Well, this time I need 10 yes, extra yes, huh? If it is clear, great. Alhamdulillah, I have very smart students. Now, we come to the, oh, what is this? Interesting part, huh? I don't know why it is going to the downside. Let me see if I can move it to Okay, C1. Oops. Okay, and then I can delete this one. So C is equal to C1. This is my text join. This text join is equal to, okay, guys, this is same as inner join. Did you see that? This is same as text join is same as the inner join. And referential join is also same as inner join. But I heard or read somewhere that referential join is faster. Okay, how it is faster? No idea, but it is faster than the than the other one. Okay, so text join is same as inner join. Referential join is same as inner join. Now, if you see here, we have like calculation view. Okay, this is revenue actual. Okay, so this is calculation view. We got a table. We got a, of course we are joining different tables to make our calculation view. So calculation view is also a table, and based on that table we draw the chart. So actually, the calculation view has a data on the base. So this is the data, yani actual revenue. Okay, this is my actual revenue. And now if you see here, this is my planned revenue. This is what I planned. Yani I planned for 400,000, but actual revenue I received 434,000. See that? Now, if you see, both are having 4 columns, same types. Year column, product column, AP indicator, revenue. Now, I want to join these two tables. I want to get all the data from this table and from this table. So what I will be doing, I will do the union. If you see, I did the union and I got all 3 records from here, 3 records from here. All 6 records are available in this new union operation. So if you want to join that, if you want to get all the data from both tables and you want to use it, you have to use union. But remember, the data type and the column must be same of the 2 tables. The column and the data type must be same for the 2 column. It doesn't matter they have different name on the top. That is no matter. But the number of columns and the type of data must be same. Similarly, you can have like these are the 2 tables that we are doing the union. We can have 3 tables, we can have 4 tables, 5 tables, 6 tables. You can do the union. Is that clear, guys? Okay. Now, if you see, we have a calculation view. Actually, calculation view is the it has a type like you can say that attribute view and analytical view. This calculation view is of type cube. You remember that? We have 2 types of calculation view is of 2 types, cube and the dimension. Okay. So this is what he's trying to tell you, that this cube is visible to the reporting tool. What is the reporting tool? You know, the web IDE is your reporting tool. Lumira is a reporting tool. So these are available to, you know, so people can see the results, people can see the data, people can see the charts from cube. Okay. But dimensions, they are not visible to the reporting tool because this is a data table. What do you want to do with that? And it does not support data analysis as well because it is, you know, what you're going to find from the cities. Huh? You have like cities is a dimension, country is a dimension. What do you want to see? You will see the dimension plus the fact table. That is the one that will give you the output. So that is why. So dimension does not is not visible. If you say I'm going to display the dimension table, well, you can display the table as is without creating even dimension. So if you created a dimension, then this dimension is not visible to the reporting tool. You cannot see on the results. It doesn't support the data analysis and can be used as data source in the calculation view. Bus. This is the job of dimension, that you can use it in the calculation view. SQL access is not visible to the reporting tool. Or you can get the data. You can get the data on the screen using the SQL statement. Bus. It does not support the multi-dimension reporting. No problem. So you cannot use it in the cubes or in the calculation view. You cannot use this one. You can only use dimension, or you can use cube. Even dimension is not visible for the reporting tool, to Lumira or on the web IDE or something like that. You cannot. Only this will be available. Guys, I'm going fast. Is that clear to you guys? Now, calculation view of type dimension. Huh? When I say type dimension, means I'm looking for, you see here, we have a customer table. This is a customer table is used for the attribute view. I have columns. Sales organization is another column. Is having language, and there's a description of the language. This is a sales organization. Country table is there. So I'm creating a calculation view of type dimension with 3 tables: customer, sales organization, and country table. You see? And as a whole, if you see, we have 2 types of data: German data, US data. Germany has like 2 sales organizations. America has 2 sales organizations. Like that. You see here. And it has a language and all those stuff. Now, when you create a view, when you create a calculation view, guys, we will start with the tables. This is my table, GBI demo sales table. Okay. And you see what I'm doing? I'm doing projection. You remember we can do projection, aggregation, join, union, rank. Some of the examples are available here. So we do the projection. Yani, projection means I want to display all columns from this table sales. And I will pass on this to the aggregation. Aggregation needs some variables to do some calculation and to filter the records and something like that. Then I will be passing on the aggregation to the ranks. We'll do some kind of more input parameters. We'll give some input parameters. Then we will join this demo sales with another table, that is a rank table or something. And then we will do the joining of these 2 tables in this place, and this semantic will display me here I'll be ready for my view to display the data or to display the charts or whatever I want to do the analysis for my predictive analysis. So if you see, I'm using aggregation, I'm using projection, I'm using join, I'm using rank in creating. This is basically graphically I'm creating the calculation view. So when you will be doing this, you will know how to. So this looks easy, Instead of writing the statements and programming languages, no, they just created these images, and it will write the program actually in the background. It is writing the statements. It is writing the statements. So at the bottom, what is that? Projection customer. If you see here, the projection customer. means it will project, it will display all columns of the customer table. Then I'm joining the customer table with the country table. Okay. And this will be a joining on text join. You remember C is equal to C1. You see here, text join C is equal to C1. And I will get wherever it will match. Only the matching one I will get. So I'll get the matching one, the country on matching one. Then I will, this is my customer and country. Now I will be joining this kullu shay, yani customer and the country is by join one. I'll be joining it with the sales data. You see the sales sales organization, not the sales data, sales organization. So this is my third join. Two join here. This is my third join. I'm joining with the join one and the sales data. Join one is what? Is the customer and the country. And then this is a projection of join two. Yani whatever is there, please display everything from the join two. Join two mean customer table is linked with the country table, and kullu shay is linked with the sales data, sales organization data. So yani I want to display all three. So this is my dimension view, by the way. So I don't see any fact table, only projection, joining, projection, joining, projection, joining. At the end, projection. That's it. So semantic is like, at this point, you can configure the fields. You want to show some field, you can hide the fields. Okay. And in this part, in this projection, you can determine the final column, what columns you want to, display in the output. So this is the place. So inshallah. Now, so calculation dimension view text join. Okay, if you see, this is the, where is that? This is the customer table that is linked with the country and the sales organization. You see that? And this is text join with the, you see, with this table. So we are getting the country from this table, wherever it is, the language is matching. So the language is D. So it is only picking the D, yani D here and D for USA. Only the D language is picked up. I think they made mistake here again, and the D is this, and E is like USA, something like that. Okay, English. So only D will be available here. You see here, Deutschland is available. No, I'm sorry. This is E. I think this is D, and because if it is English, then Germany will be displayed, not the Deutschland. Yeah, I'm sorry for that. This is my mistake. Okay, guys. So if language is E, then it will display Germany. So yeah. And this is what we are doing the mapping of the sales organization, customer, country, sales organization, and short text. This is the short text of the country, short text of the country. So this is my join view, and this is my dimension view. And dimension view and the text join, dimension view and the text join. So we will have like now calculation view, cube type. And this will be a star join. Huh? We have a customer table, we have a product table. They are the two dimensions. Huh? And this is my fact table, sales fact table, because I'm having like pieces sold. This is the one that I'll be calculating. We can also have like calculated column, and we can also have some restricted column. You see here, we can do the calculation. Inshallah, we'll be doing the calculation. You see here, revenue minus discount. This is one calculation. And I say, this is the column name is net revenue. So this is my calculated column. When I will be running the program, I'll be running this calculation view. I'll get this one. And I'll get this calculated value. And this is my calculated column. It is possible that you can have calculated column. Okay. And this is my restricted column that I'm putting some restriction. What is the restriction? Putting condition, Yani the year is 2007. Khalas. Only year 2007 will be included. So this is my restricted column. I put a condition that I only want to see this year data, not any other data. So basically, in this, we have like fast aggregation. Guys, this tables, the fact tables and the dimension table, they are the detailed one. Any 100% transactions are available in the real format, original format. So we don't have any aggregation. We'll do the aggregation when we are running the report at the same time. Why? Because we are not reading from the hard disk, so there is no slow chance. So it will be fast, and it will do the aggregation on the fly whenever we run. Because fast calculation on database level. Why? Because database is available in the RAM. You see here, we save and build the model. As soon as you save, computer automatically compiled. Okay, when you save, computer automatically compiled, and you see we get the result like that. These are the tables. These are the columns. These are the dimensions that you are writing here, and this is what we got. If you want to data preview, we did that, open data. We double click on that. We open data. We see the data preview as well. And that's it. Any question, guys? Maybe I teach so well, there is no question.